Hello, future velocity graph expert. A lot of people have been expressing some frustration in trying to do these types of questions where you're taking a velocity graph and turning it into a position graph, that I'm not telling you what to do, that you try to ask me what to do and I say use your notes. I just point to this sentence over and over again and ask you to read it to yourself or write it down or something. I just point to this example over and over again, and that's not helpful for you. So I've tried to break things down step by step here to give you lots of problems to practice on this sheet. There are so many examples here. There are 6 examples for you to try. I'm going to show you how to do one of them, and then you're going to practice every step to make sure that you get it. Because velocity graphs aren't actually that hard, but they are really potentially confusing, as you have seen if you've tried to do them. I'm actually going to do this example, this second example, and then leave you to do this one on your own, because I think this one's a little bit more straightforward than this one over here. Let's see what it looks like. The first step here is to draw dotted lines. Use up-down dotted lines to annotate moments when the graph changes. Here's what I mean. I see that the velocity graph is changing here. It starts at a value of 1 and drops down to 0. So I'm going to annotate that moment with a dotted line, not just through the velocity graph, but down through the position graph also. That's kind of like these dotted lines in the notes that you took. I'm going to do that for every place on the velocity graph where it's changing. And it looks like there are 4 different sections of the velocity graph here. This is important because anytime I see the velocity change at a specific clock reading on this graph, the position is going to change in a different way on the position graph. So we're looking for that connection, and those different sections of the graph, 1, 2, 3, 4, will become important later. Step 2. Annotate the velocity value. Annotate the value of the velocity graph in each section. So that means actually write down the velocity value with units. The velocity value here is 1 meter per second. I can see it. The value of the graph is 1 meter per second. The value of the velocity graph here is 0 meters per second. The velocity value here is -1 meter per second. Notice it's on 1, but it's on the negative side of the axis, so the value is -1. And then here it looks like it's -0.5 meters per second. Again, all I'm doing is reading the value of the graph on this axis for each of these 4 sections that I identified. Step 2 is done, and we're on to step 3. Notice step 3 has a star by it. That means that step 3 is the most important step. It is the most difficult step. It is a step where you are likely to make a mistake, so you need to do it very, very carefully. Choose an initial position and count out the slope using the velocity value. Choosing a good initial position is a little tricky sometimes. Sometimes you might choose 0 and discover that the graph ends up going negative, so you would need to choose a different initial position. Any initial position can work. You just want to make your graph so that it fits on the axis that you can use. I'm going to try starting my graph in the middle somewhere. The most important thing that you understand is that the first value here, which in this case is 1, has no connection at all to the first value here. We could start this graph anywhere and it could still be correct. The idea behind counting out the slope using the velocity value is saying this. We know that this velocity value is 1 meter per second. So we need to draw a line with a slope of 1 meter per second on the position graph. That's pretty easy to do. I'm going to go up 1 meter every second and stop when I get to this dotted line, because that's the point where this graph changes, where the value of the velocity changes, where the slope of the position graph is going to change. So some people like to draw dots and say, okay, this goes up 1 over 1, up 1 over 1. That's a slope of 1. Other people just can draw a line. It's kind of up to you what you choose to do. When we get to this dotted line, we need to stop because we see the velocity graph is changing and the slope has changed to a slope of 0. That means that my position graph needs to have a slope of 0. That's a flat line that looks like this. Next thing we do for the next section, this velocity value has a value of -1 meter per second, so I'm going to draw a line with a slope of -1 meter per second. Notice it's the same steepness as the +1 line here, but it's moving negative. That is, like, this is a negative slope and this is a positive slope. This last little bit has been tripping a lot of people up. How do you draw a line with a slope of, in this case, -0.5 meters per second or +0.5 meters per second? We sometimes see. We need to think about what it means to move 1/2 of a meter every second. And you can do it two ways. You can either actually move down 1/2 of a meter every second and put a little dot halfway between, in this case, 5 and 6, and then it would move another 1/2 meter in the next second. Or instead of thinking about it as 1/2 meter per second, you can think about it as 1 meter in 2 seconds. The important thing is you are drawing a line with a slope of 1/2, or the rise is -1 and the run is 2. Notice I'm drawing this line for the whole section because this doesn't change for that whole section. This whole line has a slope of -0.5 meters per second, and that is the connection between the position graph and the velocity graph. Every one of these sections has like this sentence here: the value of the velocity graph is the slope of the position graph. That's true for every section, and to work this through step by step is to check that every section is correct. So I would take this idea, take these steps one by one, and go on to this example. This is a slope that we didn't see over here, but there's something in your notes that can help you figure out what a slope of 2 or a slope of -2 might look like. Remember, of course, on the actual tests that are coming up, this is not the only thing I need you to do. I need you to actually describe the motion. I'm not going to go over that here because most people have been doing that effectively. I need you to draw a motion map. I'm not going over that here either. So this video is just about making these graphs, making the position graph from the velocity graph. And now that you've done one example, your job is to do it again. 1, 2, 3, 4, 5. That is, like, you just do it over and over again. Make sure that you get the hang of it. You can see that they get kind of interesting. Guarantee, if you give yourself some practice, you'll get it. The last thing, if you find these 4 steps to be helpful, I would write these down somewhere, or write something down somewhere in your notebook where you know where it is. One section, of course, is CVM 14, but CVM 14 might be full for you, so you could find somewhere else to write it down in your notebook.